This video will focus on how to multiply different types of polynomials by each other. Now, first of all, a polynomial, we have to understand what that actually means as a definition. So we have a list here of a monomial, a binomial, trinomial, or just a polynomial. Now, a monomial just means you have a single term, so one term. Whereas a binomial is two terms, right? So like bicycle, it means two wheels. Binomial means two terms. So as you're looking at these terms over here on the right with the examples, you can see that I'm listing different types of examples with a comma. So 5x, 9x squared. Doesn't matter what really is going on as long as it's just one thing. Whereas you see is with a binomial, you have two different things. All of our terms are always separated by either addition or subtraction. So that's how you can tell one term from a second. Any sort of addition or subtraction split those two up. Trinomial, like tricycle, means three, so three terms. So we have one addition and one subtraction. So 4 is a term, x squared is a term, and a negative 5x squared is a term. We typically use the sign that is in front of that term to describe whether that is positive or negative. So positive 2x squared, negative 3y. Polynomial just means two or more. Polygon, multi, polynomial just means multiple. So that's how we start to understand our polynomials. So our first example we will look at is how to multiply a monomial times a binomial. This is essentially just an application of a distributive property, where if we have an a out front, that would be a monomial, that's one term, and then inside the example has three different terms in here, but that would technically be a trinomial, so that a would get distributed to each part of that as you multiply. So let's take a look at these examples. Our first example is where you have a 4x multiplied by x squared minus 8. So that 4x will get distributed to both parts. That means that as we solve this, we're going to take our 4x and you're going to multiply by the term x squared, and then you're going to add to that the positive 4x multiplied by the negative 8. And as you multiply each of these parts, that would be a 4x cubed, because x times x squared, minus 32x, because of this negative 8 multiplied by 4, so minus 32x. Now in your second example, you're going to be multiplying negative 10y times a 4x and a negative 10y times a negative 30. And as we do that distributive property, we do negative 10y times your 4x, and then we're also going to do that negative 10y and multiply by your negative 30. Be careful with that negative, you need that. So the first one is a negative 40. X times y is just written as xy, and then negative times a negative is a positive 300y when you multiply these two. So be careful with the distributive property of a negative. That's where a lot of students tend to make mistakes when they're multiplying polynomials. Now when you're multiplying a binomial times another binomial, that means you have two terms. So here we have a plus b, and then our next expression is c plus d. So be careful with the grouping of those parentheses, that's important. So two terms times another thing with two terms. Now, there's two main ways to do this. We tend to really like the generic rectangle method because it has nice applications to later material that we do. A lot of people are also familiar with the FOIL method, where you're talking about the first, outer, inner, and last. So when you're looking at grouping all the things that you have to multiply. And that's a fine strategy to use if that makes sense to you, and you can combine your like terms after the FOIL method. But the generic rectangle method is really nice, like I said, for other material that comes up later. So what it is, you just take each of your terms, so put a and a b, so you separate your rectangle into different parts based upon how many terms you have. So this would be a square, since two terms by two terms. And then you just multiply within each rectangle. So a times c is ac, b times c is bc, a times d is ad, and b times d is bd, right? So you do all those multiplication steps. And then afterwards, you're going to combine whatever like terms you can from inside this rectangle, just like you would combine your like terms from the FOIL method. So let's look at some examples. So these examples, you can see that we have two terms, 9x minus 5, and then 4x plus 3 that we are multiplying. So we're going to use a generic rectangle to multiply this. So as you create your generic rectangle, as you label each of your lengths, you use each of the terms. So 9x and minus 5 are going to go in two of our dimensions. It doesn't matter whether you put it on the bottom or on the left. I just chose one of those sides. So you do the same, and that means on the other side you're going to put a 4x and then a positive 3. So now as you multiply these, you multiply within each of these boxes. So 9x is going to be multiplied by 4x, so that gives you a total of 36x squared. 4x times negative 5 is a negative 20x. 9x times a 3 is going to equal a 27x, and 3 times negative 5 is going to be negative 15. And now from here, we just have to combine our like terms. So that means that this would equal 36x squared, because that's our only x squared term, a positive 7x, because negative 20 plus 27 is a positive 7, and then negative 15. And that would be your final answer for the product of this expression. So we're going to repeat for the second example. Note this one has a 7x squared, but it doesn't change the fact that it is a binomial, right? There's one term and a second term multiplied by another thing with one term and a second term. So we're still going to use a generic rectangle to multiply. So same idea as before. I tend to put my first expression down on the bottom, so just out of habit. So that's going to be 7x squared down here, and then make sure you write the negative 10. And then on the other side, you'll put 6x and make sure you write a negative 8. So I like to put the sign with the expression or part of the term that we're multiplying out. So now as you multiply each part, you multiply the dimensions by each other. So this would be 42x cubed, and this would be a negative 56x. When you multiply 6x times negative 10, that is negative 60x. And then you're going to have a positive 80 when you multiply negative 8 times negative 10. Now you're going to combine your like terms, and you only have one term, which is an x cubed, so that's 42x cubed. Negative 60 minus 56 is a negative 116x, and you have a positive 80 when you combine those like terms. So either way you do it, you have to multiply every term by each other, whether it's FOIL or generic rectangle. The generic rectangle does a nice job of separating out each of your products so that it makes it a little bit